Okay, so let's talk about exceptions now. Exceptions are nothing but exceptional events in your programs, right? So basically, you've got a set of statements, and when the flow of control simply this, when an exception occurs in your set of statements, the flow of control simply disrupts. So let's say, for example, you have got 10 lines of codes in some method, okay, and there is an exception that occurs at line 5. So your code from line 6 onwards will simply not execute because there was some exception, there was some unwanted situation which had come in at line 5. So your control will simply come out of line 5 and line 6 through 10 will not be executed at all. So you need to handle these kind of exceptional cases in your programs and handle it well so that your overall application state is not changed or modified due to exceptional conditions, right? And you can actually accordingly throw a relative message when you get some exception in your program, right? So first let's discuss about the hierarchy we have, the exceptional hierarchy. So at the top of this hierarchy we have the throwable class, okay, and we have error and exception which extends from throwable. So what's the difference between error and exception here? So we always know that error is nothing but it's an error condition, right? And we just discussed that exception is also nothing but an error condition. It's an unwanted flow in your code, right? So basically both are error conditions. So why do we have two different things, errors and exceptions? So the basic difference between error and exception is that errors occur due to something that is out of control of your code or your program, right? There the error occurred because there is something which cannot be controlled the way you write your code, right? Or say for example, out of memory is an error. So you get out of memory error when there is no more space memory available to cater your programs and files, right? So you at that point of time you get an out of memory error, and this is something that you cannot control at all in your code, right? You can't do anything about out of memory error from your code. So if it occurs, it simply occurs. There's no way you can handle that, right? But when it comes to exceptions, exceptions are special conditions that take place due to whatever you have put in your code, right? So let's say, for example, I'm trying to access a file, right? And there is a part in my code, there is a piece of code in my program which actually tries to retrieve the file from the hard disk and read some values from the file, right? And in a case where the file is not there on the in the given directory, it's going to throw me an exception, right, saying that file not found exception. But this is something that I can handle in my code, because if I don't put that code to fetch the file, or I put in some alternative code, if the file is not present, I can handle this exception within my code itself, in my Java program itself. Whereas for an out of memory exception, for an out of memory error, I can't do anything in my code. So that's the basic difference between error and exception. Exception is something which you can handle in your programs, whereas error is something out of reach of your programs, right? So again, when you talk about exceptions, you've got two different categories of exception. One is the checked exceptions and the other is unchecked exceptions. So there are certain exceptions that you compulsory need to check them. And what do I mean by checked exception? It means that I need to handle those exceptions. It means that whenever these kind of exceptions occur in my program, I need to provide an alternative path to handle that exception, right? And do whatever I need to handle and give the appropriate message to the user, right? So say for example, file not found exception, it is a checked exception. Wherever in my program I write a code to get a file, to fetch a file, I definitely need to handle a scenario where the file is not found. Okay. So If you don't handle exceptions which are checked, the compiler is going to throw an error saying that you have not handled these exceptions. And the other category is unchecked exceptions. So these kind of exceptions, even though they occur in your program, you don't have a liability to handle these exceptions in your program. You can simply skip them. So let's say, for example, you are working with arrays and you are trying to fetch array values based on indexes, and you just ran out of bounds. Right? Say the array length was 10 and you're trying to fetch a value from index 11, right, position 11. It's going to throw an out of bounds array exception. But still, you can simply be safe by not even implementing, not even handling this exceptional conditions, right? So you need to know what are the checked exceptions and what are unchecked exceptions. So things like array index out of bounds exception is an unchecked exceptions. You can handle this exception, at the same time you can even ignore to handle this exception, right? So that's about the exception hierarchy and what the differences between all of those are, right? Okay, now let's see what will we do when we have an exception in our code. Right? We just discuss what are different kinds of exceptions and what to handle, what not to handle. Now here whatever we'll be discussing would be exceptions that be mainly checked exceptions, right? Because you don't usually handle unchecked exceptions. So here on whatever we would be discussing is would imply for checked exceptions. Okay, so there are two things you can do when you have an exception in your code. Okay, the first thing is you can handle the exception using the try catch finally block, right? So what you do here is whatever code that has that can throw an exception, right, you put that in the try block, right? So I'm assuming that whatever code I'm putting in this try block, there is a chance that it throws an exception. So say for example I'm trying to access a file here in this try block, so there is a chance that it can throw an exception, but it might not throw as well. Okay, so what you do is you put exception prone, error prone block in a try statement, right? Within a try block, you put the error prone block of code within the try block, and you handle the exception in the catch block. Okay, so what you are going to catch? You are going to catch the exception. Okay, so even though we saw that exception is the highest at the top of the hierarchy, right? The exception class is at the top of the hierarchy, but under the exception class there might be a number of subclasses, right? Like say for example file not found, error index out of bounds, and so on. There are a lot of exception classes which are subclasses to exception class, but exception is at the topmost level in the hierarchy, right? So you can either catch exception itself or you can catch the subclasses itself. So if I'm trying to work with files in this try block, I can catch a file not found exception. Okay. And what are you going to put in the handle exception block? What are you going to put basically in the catch block? You're going to put a code to handle that exception. So let's say for example that I'm trying to create a file or get some values from a file in my try block. I get an exception when the file is not present. Say for example file not found exception. So I'm going to handle the file not found exception by giving that exception in the catch block, right? I'll say catch file not found exception, and in this catch block I'm going to provide an alternative to that exceptional case, right? So let's say I'm simply going to give the user a message back saying that the requested file so and so is not found at the location, right? So that's what I'm going to do in the catch block. I'm going to handle the exception in some other way. And what's up with finally? So finally you put whatever cleanup code you would like to do, right? Like say for example in try block you work with files. So whenever you open a file you need to close a file, right? So what you do, where do you put that code? You put that in finally. So all the cleanup code you put in finally. And why do we put the cleanup code in finally? Because why can't we put it in try block itself? Let's say that you open the file and you started reading, and somewhere in between there is some exception, and your code that closes the file is at the end of the try block. So if there is an exception in between, the code, the control wouldn't come to a place where you are actually closing the file, right? And it simply comes out of your try block and it goes to the catch block, and you handle that exception in catch. And nowhere in this code you are actually closing that file, right? Or in similar case, if you are working with connections and all that stuff, you're not even closing the connection, and which will lead to a number of open connections, right? So in order to handle such cleanup code, you put all that into the finally block, right? So this is the basic structure of the try catch finally blocks, where you handle exceptions. Okay, but let's discuss what's the order in which you can put that. How in which order is it called? Okay, so tries, whatever you put in tries called for sure. You can be sure that whatever is there in try will at least be executed. It will at least start executing that code unless there's some exception in between, right? And if there is an exception, your control will go to the catch block where you can handle that exception, right? And finally, your finally block will be called. Okay. Now let's assume there was no exception in my try block. What would have happened? My try block would have been called, and since there was no exception in my try block, my catch block will not be called, right? But my finally block would still be called. So irrespective of whether there was an exception in the exception code or not, or there was no exception in the try block, the finally block will be called for sure, right? So you can safely put all your cleanup code in your finally block, because irrespective of whether there was an exception or not in the try block, your finally block will be called, right? So this is the best place to put all the cleanup code. Okay, right. So here's another scenario of try catch finally. So as we've discussed earlier, we can have a number of subclasses to the exception class. So one such example is file not found exception, right? So let's say I'm dealing with files in this try block here. Okay, so and I want to handle these two conditions differently. I want to handle, if there was a file not found exception, I want to handle that in a different manner. And if the file was found but there was some other error in my try block, I want to handle that in a different manner, right? So what I'm going to do now, I'm going to give multiple catch blocks here. So I'm going to say first I'm going to try to catch the file not found error. If there was file not found error exception, it's going to handle that code in this catch block. But if there was no file not found exception, it's going to handle that in this catch all block, right? When I say exception, all kinds of exception could be caught here, right? So it's going to go into this catch block, right? So this means that I can give any number of catch blocks right after the try block, but there is one rule to it. I should always catch the subclass exceptions first. So file not found is a subclass of exception class, right? So I can put that before the place where I'm actually handling the exception block. Okay. So if there was any exception class which is a subclass of file not found exception, I want to handle that exception as well, I need to put that before the block where I'm actually handling the file not found exception. So you first handle all your subclass exceptions and keep going down handling your superclass exceptions, right? So if at all you have any subclass exception, put them first, and in the end you're going to put the exception. You are going to handle the exception class, okay, which will take care of all the exceptions. So we can have multiple levels of catch blocks as well. So this is one more way you can handle your exceptions using try catch finally. Okay. So this is all about handling your exceptions. But there is one more thing when you can do when you have exceptions in your code, and that is you can throw exceptions to the method which actually call your method. Okay. So let's say there is a class which I have two methods, method A and method B. And from method A, I'm making a call to method B. Okay. And there was some exception in method B. Okay. And let's say that method B is nothing but this exception method here, right? I can simply say throws exception and I can write whatever code in my method without having to write the try catch finally combination kind of thing. Okay. So here what I'm doing is I'm simply throwing this exception to the method which actually made the call to the caller, right? So if method A calls method B and there was an exception in method B and I have this throws declaration for method B, it's simply going to throw that exception to the method that called this method. So that would be method A. So again in method A, I either have to handle that exception using try catch, or I can again throw that exception to the higher method as well. So in the end, it simply goes up the hierarchy and keeps throwing the exception to the method which actually makes the call. So this is how you work with throws. So basically, when you have exceptions in your code, these are the two things you can do. You can either handle your exceptions using try catch finally, or you can throw the exception to the method which actually called your method. Okay. So apart from these standard exception classes, you can write your own exception classes, right? And you simply write a class and say extends exception, and there you are. You have your own exception class, and you can throw and catch and handle your own exception class in a similar fashion as we have seen here. Okay. All right. So now that we have discussed what the whole flow would be for exceptions, let's just have a look at this visually. What all you can do when you come to exceptions. What's the flow in your try catch block? Okay. So first you put all your exceptional code in a try block, right? And then you're going to see handle exceptions in catch block. Do you want to handle exceptions in catch block or not? So one thing probably I forgot was it is not really mandatory to have a catch block as long as you have a finally block, right? So if you want to skip the catch blocks, you can skip them, but you definitely need to have a finally block them, right? At the same time, the finally block is not really mandatory. You can simply ignore finally block. So you can simply have a try catch combination, or you can have a try multiple catches finally combination, or you can have a try catch finally combination, or you can have a try and finally combination. So these are you should have one of these four combinations in your try catch thing. Okay. So let's see here. So first you are going to check if do you want to handle any exceptions. If yes, you are going to handle that exception in the catch block. Okay. Now you are going to see if you want to handle any more exceptions. Any more exceptions in the which are nothing but super classes of the exception which you just handled, right? If yes, again handle that exception and again make that check. If you are done with handling all the exceptions, you are going to check if you want to execute the finally block, right? If yes, put the cleanup code in finally block and end your try catch. Okay. So similarly here in handle exceptions, if you don't want to handle any exceptions in the catch block, as I said, you should have a finally block here, right? And you put the finally block and end it here. And if you handle exceptions, it would go here, right? And once you are done with exceptions, you have a choice. You can execute finally, or you can simply ignore finally. If you want to ignore finally, simply go here, no, and you can end your try catch finally. So this is all about exceptions.